Let's find the coordinates on the 12-sector unit circle. In other words, let's find the coordinates of these intermediate points here on the 12-sector unit circle. The 12-sector unit circle is broken up into equal sectors of measure 30 degrees. So there are 12 sectors of 30 degrees. Now, if we extract this triangle right here, this triangle, if we knew its side lengths, would dictate what the coordinates of this point would be. This triangle is the 30, 60, 90 triangle. And over here, I have a picture of that 30, 60, 90 triangle in combination with a reflection of it, where this is 30, this is 60, and that's 90. So in other words, we now have an isosceles triangle, that's an equilateral triangle, and that equilateral triangle has each angle of 60 degrees, and if all the angles in a triangle are equal, that means all the sides have the same length. And what I'm going to do is choose the side length to be 2. This side here is also of length 2, but I'm going to split that. Right here we have it split in half, so we're going to do this and call that 1 and 1. So now, what I want to do is imagine that 30, 60, 90 triangle right here, where we have a 1, a 2, 30 degrees and 60 degrees. And we don't know what this side is. Let's just call it A. What we do know is that we have a right triangle, and we can use the Pythagorean theorem there to figure out what A is. So we know that the hypotenuse squared is equal to the sum of the squares of the legs. 1 squared is 1. We subtract it to the other side. We end up with A squared is equal to 3. And that tells us that A is equal to the positive square root of 3. And we choose the positive square root because it's the side of a triangle. All right. So that tells us then that we have this scenario. And what we want to do is modify this a little bit. We want to modify this because when we look up at our triangle here in the unit circle, if this is in the unit circle, the hypotenuse is 1. Now the corresponding value down in the triangle that we just created has a diagonal, or a hypotenuse, of 2. So what we're going to do is use a property of similar triangles. We're going to create a triangle that is similar, that does have a diagonal of 1. So we're going to recreate this triangle, and we're going to scale it. And we can scale it by dividing each side by 2. So that would be a similar triangle. If we divide each side by the same number, we've created a similar triangle. In other words, a triangle that has the same angles. And now, the triangle that we have here, this triangle down right here, matches this triangle up here. The hypotenuse is 1 in both cases. That tells us that the side length of this triangle is root 3 over 2 here, and the side length here is 1/2. Therefore, the coordinates of that point right there have to be root 3 over 2, comma 1/2. And now we're golden. Now we can use symmetry to find the coordinates of the other 7 points that I have highlighted here. So this point down here has the same x-coordinate as the point above it. And the y-coordinate has the same length as the y-coordinate above it, but we're going down into quadrant 4, so we have to put a negative in front of it. In a similar way, if we're to look at this point right here, we see that the x-coordinate is shorter than the y-coordinate. And so what that means is that we're simply going to swap our coordinates. We're going to have a 1/2 as the x-coordinate and a root 3 over 2 as the y-coordinate. If we move over to quadrant 2 right there, we see that these 2 points have the same y-coordinate. So that point right there is going to be negative 1/2 comma positive root 3 over 2. And we can use symmetry in a very similar way to find the coordinates of this point, this point, this point, and this point. So we see that on the 12 sector unit circle, the 8 intermediate points all have coordinates that involve root 3 over 2 and 1/2. And that's how we do it. Hope this helps.